All right. Excuse me. So we have quadratic formula proof, right? The quadratic formula, if you don't know, if you've never seen it, it's right here. It's one right here in the middle, right? X equals, and then all this craziness going on here. Right. It's really cool because when you have a quadratic, you can just identify what's A, B, and C, which I'll go over in a second. You plug them in, and it gives you the values for X, right? Where Y equals 0 gives you the X intercepts. Okay, what's really cool about this is that it works every time for any quadratic, and so does completing the square. Um, Factoring, which everyone usually prefers, they find it easier. It's nice and convenient, but when it works, right? Because it doesn't always work. But how you might be wondering if you ever wondered how do we get this? How does this even happen? Right? How does x equal all this nonsense? Right, what actually comes from the standard form of a quadratic right here. If I complete the square on the standard form of a quadratic, then I will end up with the quadratic formula where x equals this, right? So let's go ahead and go to the standard form of a quadratic and let's complete the square on it. Okay, so I brought the procedure, the completing the square procedure over here. If you need to reference it, that's totally fine. Okay, but you just complete these steps and let's see what happens. All right, the first two steps are actually interchangeable. If you do these out of order, it won't matter. Okay, so but you want to make sure that your leading coefficient here has got to be one, right? For completing the square, whatever number is in front of x squared here, divide everything by that because you need one to be in front of x squared. Sometimes it is, not always though, right? But long story short, let's divide everything by a. Okay, so the x squared gets divided by a. All right, so there's the a here and the a that are divided by will, of course, cancel each other out. The bx gets divided by a, and the c gets divided by a. Technically, even the 0 gets divided by a as well. Very cool. First step down. All right. Next, you want to move your constant over, right? Whatever's here, right? It's usually some number, right? Well, here A, B, and C are just numbers. So we're going to move this over to the right hand side. Okay. So I have x squared plus bx over a. Now it equals negative c over a. Very cool. Now the next step, this is where the magic in completing the square really happens. This is what's going to give us that perfect square trinomial on the left-hand side and make it factor just so beautifully. Okay, you want to take the number in front of x, and in this case, the number in front of x is b over a, and you want to take half of that. Well, how can I take half of this quantity here? Put a 2 in the denominator. There, you just cut it in half, right? Easy day. Now you want to square that, okay? And you want to add that to both sides. There you go. Now it's squared. This is what we're adding to both sides. This is what's going to allow us to factor the left-hand side very, very nicely. So my left-hand side is now x squared plus bx over a plus our new friend here, b over 2a, b divided by 2a. That's being squared. And remember, that's being added to both sides. Yes, minus c over a. Perfect. All right, cool. Okay, so the left-hand side, right, will factor. Anytime you're completing a square, the left-hand side at this point in the procedure will factor to be a perfect square trinomial. So our two binomials will look the same. All right, so two numbers that multiply to what's here, and they add to the number in front of x. Right? And that's going to be b over 2a, right? You can see the product is here. It's just that something squared, and the two halves added together will make the whole. X plus b over 2a. All right, and that that mystery value, it's always going to be whenever you cut this in half. See what I'm pointing at? This coefficient of x, whenever you cut that in half before you squared it, that's what this is always going to factor to, right? When you're completing the square, right? X times the quantity of x plus b over 2a, right? Equals, and you'll see here I have a quotient to a power property where the b's being squared, the 2 and the a are also being squared. So let's go ahead and do that. B squared minus, and then 2 squared is 4, and then a squared is just that. Looking good, looking good. Okay, so you see on the left how my two binomials are the same. All right, and that needs to happen every time. If you're trying to complete the square and these two binomials are not the same, something's up. All right, so we check that. But because they're the same, let's rewrite this as the quantity of b over 2a, I'm sorry, x plus b over 2a, that quantity squared, right, equals, and we have two fractions here on the right, right? So let's combine them. You can see the, by multiplying each fraction by the denominator in the other fraction is the route I would go. Yeah, okay. So what does that mean? The denominator in this fraction is a, right? So I'll multiply left by that, a times b squared minus, and then 4a squared times c, and that's all being divided by the product of the two denominators, 4a squared times a, 4a cubed, right? Just combining the two fractions, right? And you can see here on the right, I can factor out an a from this term and this term on the top. So let's go ahead and do that. That's probably a good idea. I think that's a good idea. So our left-hand side is going to remain the same for now. X plus b over 2a, that quantity is being squared. And I'm factoring out an a from my numerator. AC, 4a cubed, right? And the reason I would do that is because I can cancel this a. I have three a's on the bottom and one a on the top, right? So I can cancel. I can start crossing stuff out now. This a is going to reduce with one of these a's, so that's now a 2. Nice. Okay, so our left's going to stay the same for now. We're just going to hang out x plus b over 2a. That quantity is going to be squared. All right, in our new right-hand side, b squared minus 4ac, which will be known as the discriminant. We'll get a touch more on that later. Divided by 4a squared. Okay. Don't try to reduce these a's or these 4's. That ain't going to work, right? Because then you're neglecting the fact that b squared is also being divided by that. If it wasn't for this minus sign, you could totally do that, but please don't fall for that. Okay. You can split these up, which we'll do in a second after we do something about this 2 here. All right, so I'm going to take the square root of both sides to get rid of this exponent, this 2 here on the left. So I'll take the square root of the left. That exponent will go away with the square root sign, the radical. And what I have on the right, I'll just go ahead and square root this whole bad boy here. B squared minus 4ac divided by 4a squared. Cool. So you'll see on the right here, I have a quotient being raised to an exponent. The square root is an exponent, right? So all the properties, it's an exponent of 1/2 to be exact. All the exponential properties certainly apply here, right? So what I'm getting at is that I can rewrite this with a square root on top and a square root on the bottom. And that works out pretty nice because I have a product down here. This radicand is a product. 4a squared. It's 4. I can take the square root of that. It's a perfect square. as well as a squared. I can take the square root of that, right? I don't know what a is, but I know what the square root of a squared is, right? Yes. X plus b over 2a equals. Our numerator is going to say just the same for now. Radio. Okay, and on the bottom, we've taken the square root of 4 to get 2. We've taken the square root of a squared to get a. Okay, so we're almost done. Actually, once we subtract b over 2a from both sides and then put the two fractions together, we'll, we'll have it. We'll have it. Okay, so let's go ahead and do that. I'm going to subtract b over 2a from both sides. So x equals negative b over 2a. All right, plus or minus, because we did take the square root, right? Yeah. The square root of b squared minus 4ac. Very cool. Over 2a. So my right-hand side is two terms, right? And both these terms have the same denominator. So let's just go ahead and combine them so it's nice and pretty, right? Because both the negative b and my square root here um, is being divided by 2a. I want to make sure it's very, very obvious everything being divided by 2a. Perfect job. Very cool. We did it. Yay. That's so cool. Let's go ahead and circle our final answer. That's what x equals. So yeah, that's it. You literally take a quadratic that's in standard form, identify a, b, and c, plug it in here, and that's your values for x. That's when y equals 0. That's the x-intercepts. Yeah, so that's pretty much it. All right, awesome. Awesome. Very cool. Yeah, very cool.